Hello, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to part 7 of Beginning R. The course material is at chriswoods.com/beginning R, and now we're looking at the files page that's here. Now everything we've done so far has been completely self-contained in the script, so every time we run a script it's used the data that only existed in the script, and so you get exactly the same output. Now the power of programming is to be able to take the same piece of code but apply it to lots of different bits of data to get different results. Now one common way in which this is done is by writing a script which can analyse a data file. So to do this we're going to have to learn how we can open and then read data from a data file. Now what I'm going to do now is I'm going to close dict.r, I'm going to create a new R script, and I'm going to call this R script file.r. Okay. Now, the way we open a file is we use file. So I'm going to get here lines, and from lines I'm going to read lines, file, file.r. And I'll explain how this works once we've run it. So for line and lines, then we will print the line. Okay. So if we run this script first, so r script file.r, we can see what this script has done is it's printed to the screen every single line that was contained within the file file.r, which, Inception-like is the actual script we've tried to run. Now, what this has done is we have first opened the file called file.r by using this command. So file is a function. It takes the file name of the file to open, and it will then open the file ready for you to do something with it. Now, readLines is another function, and what readLines will do is it will read whatever is passed as the open file. So readLines file file.r will read every single line from file.r and will return it as a list, which in this case is lines, and each element of the list is one line in the file. That means because now lines is a list, we can loop over it in exactly the same way as we looped over lists before. So when we do for line in lines, we print line, we're literally now just printing each line that has been read in from the script. And in this case, because we opened file.r, which is the script itself, that's why we're printing the script itself to the screen. Now what would happen if we put in a file that does not exist? So I'm just going to put in a fake file name here, does not exist. And we now try and run the script. What we see is that R has stopped executing. So if it cannot open the file, it gives you a warning message, I can't open the file, no such file or directory, and R immediately exits at this point. This means that if the file does not exist, your program will not run. Now notice when we went through this, I'm going to put this back to being file.r, and then we're going to run this again, that every single line was quoted. So the double quotes, which designate the string, were printed to the screen. We can get rid of those double quotes that are printed by passing quote equals false as an argument to the print function. So now you can see the quotes have disappeared. But still, and you may have noticed there's a lot when we were printing, R is printing this square bracket 1 every time we print something. This is a technical detail of how R works because it's showing you information about what the variable is. Now you can get R to print without this square bracket 1 by replacing print with another function which is called cat. Now when we print with cat, what will happen here is if I just basically print with cat on its own, and we'll see what happens, you find everything gets printed all onto one line because cat is joining things together. It's short for concatenate. Now we want a cat with a separator so that every line is a new line, and so we need to pass in here sep, which is short for separator, and then this \n means new line, so it means print it, separating each line with a new line, and when we do that, we get the things printed to the screen nice and exactly. So I've now walked you through this first part, and we're now up to the exercise, which is here. What I'd like you to do with this exercise is I'd like to print out the R code. So the R code itself isn't actually massively useful. So let's now make a data file which you can print instead. So we're first going to make a data file called data.txt, and we're going to put this data into it. So I'm going to put this in to show you how to do it. So we're going to file, new file, and what I'm going to do is I'm going to say text file, which is down here, and it's creating a new file here, and I'm going to call this file data.txt. And now into data.txt, I'm going to copy these numbers, making sure there's no spaces between them, and then also making sure we have a new line at the end. So now we have a file that contains those numbers with one number per line. Now what I'd like you to do is edit your file.r so that it will print out the contents of this data.txt. Press pause, and when you come back from pause, I will show you the answer. Okay, you're now back from pause, so I assume you'd like to see the answer. So let's have a go at that. So file.r, first thing we need to do is change file.r. We're now going to be reading the file called data.txt. Now, just as we had before, now all of the lines have been read by readlines and given to the list variable which we've assigned to lines. So then we loop over it for line in lines, and then we can cat the line separated by a new line character. And when we do that, you can now see all of the lines, all of the numbers have been printed to the screen. Now, so far, all we've done is simply read the file and then we've printed the output to the screen, and that isn't massively useful. So the first step we need to take towards actual data analysis is to pretend that the task we're trying to do is now read in the data, and let's perform some numerical sort of analysis on it. So let's pretend we want to say add 17 to the number. So we've got each line, so the number is in each line here. So let's say now we're going to have a new number, which should be the number that we printed plus 17. So hopefully this will work. Let's see what happens. So print new number. Now when we do this and we run the script, what we'll see is R will halt again. It's given us an error here where it says line plus 17, non-numeric argument to binary operator, execution halted. Now, as we mentioned before, you can only perform numeric calculations, so plus, minus, multiplies, divide, on numeric values, so floating point numbers and integers. When we've read a line from the file, it's read in as a string. It may contain a number, but it's read in as a string, and so it's not possible to do line plus 17 because line is a string. What we need to do is we need to convert line from being a string into a number, and we can do that using as.numeric. So what I can say is new number, so number, let's grab the number itself out, is going to be as.numeric line, and then new number will then be number plus 17. And then when we print new number, we will now see we'll have the contents of the file where every single line has had 17 added to it. So this now brings us down to a series of exercises which are at the bottom of the page. And we'll go through each one in turn. So for the first exercise, I'd like you to change file.r, and I would like you to multiply every single line in the file by 10 instead of adding 17. Press pause, and when you come back, I will go through the answer. Okay, you've unpaused, so I now work through the answer. So it's just as we have here. We've converted every single line from being a string to being a number, and now we want to multiply the value by 10 instead of adding 17. So we'll do multiply by 10. And now when we print, there we are, every single line is now multiplied by 10. Okay, the next exercise was to say, after looping through the data, print out the sum of all of the data values seen. So we need to create a sum. Again, press pause. When you come back, I'll show you the answer. Okay, you've unpaused now. So we're going to create a sum now. So what we're going to do is, first we're going to have to create a total. So total we initialize to 0. Then we've got the number here. But what we want to do is, instead of printing the number, we want to increase the value of total so that it equals total plus whatever was the number we've now read. And then we can then print, paste, sum of all values is, and then we can have the total. So a little colon there. So now we've set total to 0, and then for every single line in lines we get a number from the line, and then we add that number to total, and then we print it at the end. And if we do that, there we are, we've now summed this up to 460. Okay, the next exercise, what have we got here? So now what we want to do is print out the count of the number of values that we've read as well. So we need to basically count the number as well as, so how many items have we read? So let's do that now. Again, press pause, sorry, give you a chance before I show the answer. Okay, you've come back from pause, so let's go through the answer for this. We need to count up the number as we go through. So let's create a new variable called count, set that equal to 0, and then every time we read a number, let's do count is count plus 1. Now that we've done that, what we can do is we can now add that count here, so we can say print sum of all count values is total. So let's print this, let's see what we get. Sum of all 7 values is 460. That's excellent. Okay, let's now move on to the next one. We now want the mean average of the data in the file. So how can we get to the mean average of the data? Again, I'll press pause, or you press pause, and then I'll come back and show you the answer. Okay, you've now come back from pause, so let's go and calculate the mean average. So we've already got the total and we've already got the count. The mean is simply the total divided by the count. So we can say mean is assigned from total divided by count. And then let's print this out here. Print, paste, the mean is mean. And then if we run this, we can see that the mean value here is 65.7. Okay, so now we have another, it's a lot of exercises here. So now we've got the exercise, see what happens if you run the script after deleting the contents of data.txt. So what will happen if we delete it all? And then if something goes wrong, add an if statement to fix it. So press pause, and then I'll come back. When you come back, I'll show you the answer. Okay, you've unpaused now, let's go through the answer for this. So let's assume now we've deleted all the contents. So the first thing I'm going to do is I'm just going to temporarily delete all of these lines. So now there's nothing in this file. Now when I run this script, let's see what happens. Aha, the sum of all 0 values is 0. That looks like it's correct. But we've now got the mean is nan. Nan means not a number. And this has happened because when we look at the script, we have divided total by count, and count is 0, so dividing by 0 the computer can't do it, hence why you're having this is not a number. So to fix this, we're going to have to say we can only calculate the mean if we actually have a count which is greater than 0. So we can put this into an if statement. So let's take this line here down at this point and then add an if statement at this point that goes if count is greater than 0. Let's calculate the mean. And there we are. And now when we run the script, we don't get the nan value, but if we now return all of these values to this file, we still get the calculated mean that's correct when there is data in the file. Okay, we now have the final sort of exercise in this sort of block. We want to collect the statistics that we've calculated, so the sum, the count and the mean, and put them into a summary dictionary. So I need to create a dictionary of these values where sum, count and mean are the keys or the names of that dictionary. Again, press pause, and when you unpause me, I'll show the answer. Okay, you want the answer now, so let's have a go with this. So what we're going to do is we're going to create a dictionary which is going to hold the sum and the count, and let's call this dictionary stats, sort of short for statistics. So it's a dictionary that's going to have a key of sum, which is going to start off with a value of 0, and a key of count, which is also going to start off with a value of 0. Now, that means we don't need total and count here. We're going to get the number from each line, but then instead of basically doing total and count, we're going to update stats count, or stats sum, rather, is going to be assigned from stats sum plus number. Then we're going to assign stats count from stats count plus 1. Okay. Now what we're going to do, we don't need to print this line out because everything is in stats. If stats count is more than 0, that means that we can now calculate the mean, and so we're going to say that stats mean is going to be total over count, and again we won't print this. What we can now finally print is stats to the screen to print the overall dictionary. Now if we run this, just going to make sure it's all on the screen, there we are. You can now see, aha, I've got something wrong, I've got a total that's missing. This is the thing with programming, you always make a mistake, aha. I'm using total over account here, it's wrong. R has let me know that that was wrong. This is stats count divided by stats sum divided by stats count. There we are. And again, there's our mean, 65.7, 7 values, the sum of them is 460. Okay, with that, I've now finished all of the exercises of files. That means we've now finished part 7, and so there is just part 8 left, which is our conclusion and summary. I look forward to seeing you there.